Hello, ladies and gentlemen. Today we're going to take a look and see how to find the equation of a tile problem given some figures. So here we have figure 1, and we're going to notice how it grows to change into figure 2, and how that grows to change into figure 3. So our first step is to make an XY table with the number of tiles in each figure. So we're simply going to look at the figure number, and then we're going to count the number of tiles in each figure. So here's our XY table, and we always start our tables with the number 0. Our X is our figure number, and our Y is the number of tiles. Now, the reason we start with 0 is we're going to need that to find the Y-intercept of our equation. So we're going to go ahead and do 0, 1, 2, 3, and then we're going to go ahead and look at future ones for 4 and 5. So before we do that, we're going to go ahead and take a look and count the number of tiles in figure 1. And we have 1, 2, 3, 4. So we're going to go ahead and put a 4 because there's 4 tiles in figure 1. We're now going to count for figure 2. We have our original 4, and we have 5, 6, 7, 8, 9 more. And then in figure 3, we have 9, and then 10, 11, 12, 13, 14. Now, once we have a number of these together, our next step is to find the pattern. What do I do to one number to turn it into the next? And in this case, as you can see, 4 plus 5 is 9. Now, we have to be careful to make sure that this pattern works for every single number that we know, because we are going to look at patterns that are not just adding or subtracting. We're going to be looking at multiplication and division patterns as well. So we double check that, and we know 9 plus 5 is 14. Therefore, our pattern is plus 5. Okay, we're going to go ahead and use this and extend the pattern to find out how many tiles will be in figure 4. So we're going to add 5 to 14, and that's going to be 19 tiles in figure 4. We're going to continue that to find how many tiles are in figure 5. We're going to add 5 to 19, and there's 24 tiles in figure 5. Now, this is great, but what if I wanted to find how many tiles were in figure 13 or figure 45? It would take too much time to repeatedly add 5, so we want to find a formula. We want to find the equation so we can just plug in X, solve, and know how many tiles will be in that figure. So now that we found that pattern is known by many terms. What is the change from one figure to the next? What is the growth from one figure to the next? We also call this our M, which is our slope. That's our big mathematical word, is the slope. How far up and over do we go? What is our rise over run? Now, our slope in this case, or our M, is equal to 5. Now, our step number 3 is we're going to go ahead and work backwards to find out what our 0 figure is. So we're going to do the opposite operation of adding 5 to figure 1 to work backwards to find out how many tiles will be in figure 0. So we're going to work backwards, and the opposite of adding 5 is subtracting 5. 4 minus 5 is negative 1. So we know that our 0 figure has negative 1 tiles. Now, this is important because our 0 figure, also known as our starting value, or our B, is known as our y-intercept. And our y-intercept is where that line crosses the graph on the y-axis. So our B, or our y-intercept, is negative 1. Now, we know that our formula for a line, which is adding or subtracting, is y equals mx plus b. So all I have to do to solve is put 5 in place of m and negative 1 in place of b, and I have my equation of my line. So my equation of this line is y equals 5x minus 1. Now that means if I want to go ahead and find what the 10th number of tiles is for figure number 10, I would simply go 5 times 10 is 50 minus 1 is 49. So I would need 49 tiles for my 10th figure. And we can see that that's true. If I plug in a 1 for x, 5 times 1 is 5, minus 1 is 4. If I plug in that 5, 5 times 5 is 25. 25 minus 1 is 24. So this is the equation, and it allows us to pick any x value and find where the number of tiles is or how many tiles will be in that figure.